Hi everyone, welcome back to the channel. Let us start with day 10 of Python basics. The topic name is strings in Python. So here we actually start the foundations for DSA. So this video contains the whole of four sections. The first one is string fundamentals, second is indexing, slicing and techniques. Section 3 contains of built-in string methods, and section 4 contains coding problems and their solutions. So let us start with the section 1. What are actually strings? So strings are immutable sequences of characters in Python which are ordered and indexed, unchangeable after creation once established. So which means that the characteristics of a string are ordered, indexed, immutable and a sequence of characters. The declaration methods, we can declare the strings using single quotations and double quotations and naming triple quotations also. Strings are flexible for declaration and representation options are also available. As I already mentioned, the key characteristics are ordered, indexed, structure-able characteristics, and unchangeable nature ensures data security and integrity. So Unicode support, full Unicode support with encoding awareness enables international character representation and multilingual string handling. So the basic difference between the string and other types are differentiating strings from lists, tuples, and other integers through immutability, sequence ordering, and character-specific properties uniquely. The next one is slicing. So slicing operations are here. You can see uh, start, stop, and step enclosed in square braces. So this is the syntax which is used to slice a string. The start parameter is inclusive. Stop parameter is exclusive. Step parameter is it controls the increment between start and stop values. So negative indexes are also working in strings, so which we can access the string from backward. Negative minus 1 equals to the last character, and the pattern continues leftward systematically. So this is the easiest way to reverse a string using step value minus 1 and now start and stop values. And step patterns, we can create custom extraction patterns and skip characters by increasing step value. Visual demonstrations, for example, the outputs show actual slicing results. Practical demonstrations clarify syntax with real string manipulation examples. So string declaration, single quotations, double quotations, and triple quotations, as I already mentioned. Raw strings prevent escape sequence interpretation. Prefix with R to treat backslashes as literal characters. F strings enable dynamic content interpolation. Prefix F to embed with the expressions directly in strings. Byte strings represent encoded text data. Prefer prefer the prefix with B for binary data and encoding considerations in Python. So core core importance algorithms. So this is the slide which shows and which tells us about why the strings matter in DSA foundations. So it is the core importance in algorithms, and it helps in pattern matching applications, and performance considerations are very helpful, and it is used in real world use cases, and it is a foundation for many advanced topics. So strings are the fundamental data structures, and searching, parsing, and validation operation leverage strings for text processing, data extraction, and input verification tasks. Time and complexity analysis critical for optimizing string operations and algorithm efficiency in large scale data. Text processing, data validation, and cryptography demonstrate practical string applications across industries and domains. And strings enable mastery of suffix keys, suffix array keys, KMP algorithm, and other sophisticated data structure techniques in DSA. So here we go with string indexing deep dive. So positive indexing starts from 0 and negative index starts from -1. Character access methods use bracket notation with index position of index side square brackets to retrieve individual characters from string. Error handling strategy, implement bounds checking, try except blocks to prevent index out of range errors. String search functions, find and index methods, locate position, return index of the character which substring matches, or raising exceptions appropriately. So practical indexing and sizing, the importance is substring extraction, negative step reversal, palindrome checking, and word boundary extraction and character frequency analysis. So essential string methods overview. So the transformation methods include upper, lower, capitalized, title, swap case, and the search methods include find, index, count, starts with, ends with. Upper will convert into the string into complete uppercase. Lower will convert into lower uppercase. Capitalize will initialize the first one to the capital first individual string character as a capital. The title will make it as a title. Swap case means it will change the lowercase into uppercase into lowercase. The next one is search methods. Find will return the index value. Index will return the index position. Count will represent the frequency of the character. And starts with gives the character which starts with, and ends with gives the character which ends with. The location of substrings. Validate string patterns for processing data and validation tasks. Modification methods include replace, strip, split, join, alter string by removing white space and splitting into lists and combining multiple strings seamlessly. So validation methods is alpha, is alnum, is dset, is space. This is, this returns the boolean values which is true or false. Formatting methods, format, ljust, rjust, center, align, and structure strings with padding for readable output presentation and report generation. These are essential string methods. So advanced string operations, string comparisons, string concatenations, string multiplications, membership testing, and method chaining. String comparison is a lexicographic ordering and equality checks for accurate result validation. And using plus operator, we usually do string concatenation, or also we can use join operation. So string manipulation, multiplication, which is used to repeat the strings efficiently using the hash operator for duplicating content multiple times. Membership testing, apply in and not in operators to check the substring presence in the target strings or not. Method chaining, which is used to combine multiple string operations sequentially to perform complex transformations efficiently. So the final one is palindrome validation. Let us take a string. So as already mentioned, to reverse the string, we will directly use this function, this inbuilt method. So let us check if s double equals to s1, print palindrome, else print not a palindrome. Let us run it. So it is showing the palindrome since the reverse value and the same values are equal, Ramar and Ramar. So the first one is completed. Let us go with the second problem. Reverse words in a string. Same problem. S1 s equals to Pavan. So let us reverse the string. Rev equals to s of double hashtag -1, print rev. print. So let us print the both yes and reverse yes values to know the difference. So power and reversed power. Okay. And let's go to the next problem. This is the homework problem for all you guys. Longest substring without repeating. So these two are homeworks. The first one is longest substring without repeating, and the second one is pattern matching or anagram check. And count vowels and remove duplicates. These are also extra problems. So the basic outcome of today's session is the students or the aspirants who are working with strings can easily solve the beginner string problems confidently without any errors or any confusions. So that's it for today's class. So thanks for being patient and watching, and let's meet in tomorrow's class with the concept recursion, which is a mind blending logic. Thank you. Meet you in the next class.